Hey everyone, welcome back to my coding series. Today is day 85. It's been a while since my last upload. I just finished up school, so I'm graduating tomorrow. So I just picked this random problem here. I haven't looked at it at all. I just copy and pasted it into here. Alright, so there is a lemonade stand where customer bills can buy one lemonade at a time for $5 and pay with a $5, $10, or $20 bill. It is necessary to return the correct change to each customer so that the net transaction is completely successful with a total payment of $5. Note that no change is available initially. Given an array of integers, bills, where bills of I represents the bill paid by the ith customer, return true if it is possible to provide every customer with the correct change, or false otherwise. Alright, don't you just like keep track of the change? Alright, so 5, so the change is 0. Oh, no. Okay, so once you buy, so if you buy a lemonade for $5, the bank, I'll call them, or the stand, now has $5. $10 they need, so a customer paid with $10, so now they need $5 in change, which you have. So now your remaining change, oh, I see. So now so do you have 5? So at this point, you give them $10, get $5 back, so now they have $5. Here they have an extra $5. So that's 15. Here they have 20. And for 20, they need 15. So well, we also have to keep track of the bills, I think. Maybe not, but like I don't know if there's a world where the type of bill that you have matters. Like if I pay, let's say I needed $5 back, but you only have a $10 bill, then that would be false. Okay. All right. So all I have set up so far is I just have a a test, PyTest. I don't know what this is. Oops. So that doesn't work. All right. I think it's because it could be when I copy and pasted the solution in, there was one of these from where I copy and pasted it. So why don't I just do this? Maybe it's like hidden or something. All right, yeah. Okay. So yeah, all right. So I'm wondering if the bills actually do matter. So I'm just gonna walk through the first examples. And yeah, sorry if I'm rusty. It's been a while, but all right. So 5. So I want to keep track of the. So bank, I'll make a list of integers, which is basically the bills that they have. All right. So for the first example, it is this. See the incoming bills. All right. So the bank has nothing right now. Transaction of 5 gets completed, which means now the bank has a $5 bill. 10. So now you give them your 5 and you have the 10. 5, you get an extra 5. Okay, so I think this matters because right now we have a 10. If our input was, for instance, 5, 10, 10, then I think this should be false. Because if a customer was to come right now and give us a 10, then we could not supply that because we don't have a 5. So the type of bill does matter, actually. Yeah, so I mean, is it as simple as, because in the constraints it can only be 5, 10, or 20. So I'm thinking we could just have bank could just be a dictionary of every bill type and account, and then we just check if we have the bill type that we need. But there is something tricky. So like 10, you always need a 5. 5, you don't need anything. 20, so I think this is the tricky part of the problem. So with a 20, you need $15 in change. So that can be split up into either 5, 5, 5, or it can be 5, 10. So we need to pick which one of these is better. Obviously, if we have less than 3 5s, then we should definitely go with this one. But let's say we have a surplus of both of them. But later on, I mean, I feel like the greedy way of doing it would be always do 5 and 10, because $5 bills are, well, yeah, I think actually you should always do 5 and 10. And my reason for that is there is no other bill where you give them $10 in change. There is nothing that's 10 can be applied to besides 20. So I think what we'll do is first check this one, because we want to use the 10s here because there's nowhere else to use them. And then if we can't do this method, then we'll do this method if we can. And yeah, okay. So that's the idea. So I'm going to have, so far, I'm going to have dictionary that keeps track of bank's bills. Yeah, just adjust dictionary with every purchase. And then for 20s, try using 10 and 5 before 5 and before 3 5s. Okay, so this is my idea. So if we look at our constraints and edge cases here, so bills can be just 1. So that's fine. We can just look up our dictionary. It has to be, if we have one bill, it has to be a 5. All right. All right. So let's try that. So it'll start off with 5 has 0. So the key of the dictionary will be the bill, and the value will be the amount of that bill that the bank has. And then, so this is our initial bank. And then we'll say for bill and bills. So I think the best way to do it is probably just 3 if statements for each bill. So if bill equals 5, and it's a list of integers, yes. Yes, all right, so they're integers. If bill is 5, then we don't give them any change, and all we say is bank of 5 plus equals 1. The bank now has 1 extra 5 to work with. All right. And it can only be these three. Yeah. So maybe I should just do else, but I don't know. Okay, in this case, this is a fail condition. So if we have no fives, and I'm going to write this code and assume that the bills can never be negative. Okay, so if the bank has no fives, then the answer is false. The answer is false. Otherwise, if they do have a 5, then we give them 110 and we lose 1 5. Like this. Okay, and now in this case, so we have, yeah, so if both of them are false, all right, so I'll just kind of block it out here and then we can optimize it later, but all right, so first of all, we want to check if they have at least 110 and they have at least 1 5. In this case, well, I think actually, I'm noticing in every case at the end we do bank of bill. Like the bank always gets the bill that we paid for. So I'm going to just get rid of this. And I can just take that out. All right. So if we have at least 110 and at least 1 5, then we want to give that to them. So like this. Otherwise, well, no, it would have to be, no, that's fine, yeah, okay. Okay, so if this is not true, so this is like the 10 and 5 scenario that I talked about. So if this is not true, then next we want to check if we have 3 5s. So if we have 3 5s, then we will give them 3 5s. Okay, and if neither of these are true, then we cannot give them change. Yeah, all right. Okay, so if we get to the end of bills here, then we should return true. All right, so let's see if I make a solution object here. And then I want to say solve it with these bills. Say bills. All right, so I want to solve it with bills, and then I want to print the output of that. All right. So let's run lemonade. Why is it not auto-completing? Oh, because I don't have Python. Okay, so that's true, and this is false. This is kind of what I have the PyTest for, but I'm just doing it here for now. Okay, so those work. So let me do those as tests. So assert this equals true. I'll call them samples. Actually, examples, okay. Example 2. All right. All right, so now if I run PyTest, all right, we pass both cases. Okay. How do I feel about this? I mean, it seems like a very kind of logical flow, but it heavily depends on the fact that this constraint. So if, for instance, we had we could receive any like the bill. If this was not here, if bills could be anything, then this problem would be more tricky. Because here I can just kind of handle each individual case in these if statements. And then I could just make this else, I guess. Well, no, I can't. Because it could trigger on 5. Okay. Alright, so let me just do some edge cases here. Okay, so if we have okay, so let's do single bill. And this will be, so we'll say bill, and then I want to, I think you can say yeah, was it random.choice? I don't know if this is good practice. Maybe here we should just do so single bill high, single bill low. So I'm thinking like if we have 5 as a single bill, then we should just do it. Like it should be true, and if we have one of these, then it should be false. I don't really need this extra variable here. Okay, so here this would be false. If we have one of these, it should be false. And then here, if bills is just 5, this should be true. Okay. So let's try those. Okay, looks good. So now the other interesting part of this problem that I should probably test for is to make sure that the relationship I described with the 5s and the 10s is true. So what's a test case where if you pick this one first, it could kill you? So let's give them. So let's give them. So I'm just designing test cases at this point. Because I guess I don't really know if this property would work in my code. So let's first put them in a position where they have to decide between these two. So that means that they need 3 5s and 1 10. So let's give them 3 5s. And then how do we give them 10 for change? Maybe like this. So we'd give them 4 5s, and then they'd lose 1 5 and gain 1 10. Okay, so now we're in this situation where they can pick either one. Now if we give them a 20, they have to pick either one. If they pick this one, now, okay, what if I give them 2 10s? Is this the test case? No, okay. So in this case, so they have 4 5s, then we lose 1 and gain a 10. Alright, now at 20, if they pick this option, this will go to 0, and this will go to 1. Okay, and then when 10 rolls around, they have no 5s, so this would fail. What if they picked instead one of each? In this case, then they could pay both 10s. It'd be fine. All right, so this one should be true, but it's kind of the choice that you make matters. So this should be true. Whoops. Okay. All right, I think that's a pretty good tests. Yeah, that sounds good. These look good. Okay. Yeah, so we'll all right, I guess we'll go with that. Yeah, so this is like a good little warm-up problem since my first time coming back. But yeah, this problem definitely could be a lot harder and a lot more interesting if this constraint was not here. But anyway, thanks for watching. That was day 85, I think. I'm going to start doing it daily again, so I'll see you tomorrow for day 86.